Today on CodeDependent, I'm going to talk about animation performance. In particular, I'm going to talk about approaches you can take to measure what performance you're getting. There are different elements of performance that are good to be aware of. There's different events that are sent around the system. There's different frame rates depending on what it is you're listening to. And it's good to understand sort of what's going on under the hood in the Flash player and in Flex so that you can actually be timing the appropriate thing and figuring out whether it's working for you. So I wrote a simple application so that I could track the frame rate. And then I realized, well, there's several different frame rates, so I should track every one that I care about. In particular, there's three rates that I care about. One is the animation performance itself, how many frames per second we're getting from the core animation code. This is basically how often is the timer being the timer event being sent to the animation code so that it can wake up, do the calculations, and then tell Flex to re-render the display based on the changes that we make. So that's the rate of the internal timer, which in the application I wrote is called the animation frames per second. Then there's the render frames per second. This is an event that is sent out just prior to changing the display. So this is an appropriate place to plug in if you want to make a last-minute change to the display list before it actually appears on the screen. In general, this should be the same rate as we get for animations because the way that Flex effects work is that we receive a timer event, we make the calculations, and then we say animate, or then we say update after event, and that causes a render event to be sent out and the display to change on the screen. And then finally, there's the rate at which enter frame is called. This is an event that is sent out every time we actually do, we paint a frame of the animation. And this I always associated in my mind with render. Well, if there's a higher render rate, there's a higher enter frame rate because aren't they the same thing? And in fact, they're not. Enter frame gets called every time there's an official rendering of a frame for the Swift file. So you basically set a frame rate on the Swift. By default in Flex, it's 24 frames a second. And the enter frame event will be called basically that at that rate. And if we happen to be doing more renders, if we happen to be drawing to the screen more often than that, that doesn't necessarily reflect in the frame rate or the rate at which the enter frame event is sent. So let's actually see how this works in the application. So we have a simple application with an ugly GUI here. We have a requested frame rate, so we can change the rate of the Swift file here. By default, it's 24. We have a button. We can play an animation, which is going to move this rectangle from the right to the left. And then we have some information reported here. We have the frame rate that the Swift thinks that it's running at, which right now is 24 frames a second. We have the actual frames that we're calculating internally based on handling that event and calculating an ongoing frames per second value. We have the frames per second that the render thinks that it's running at, which is the number of render events that are being sent through the system. And then we have the frames per second for the actual animation underneath. So as I click play, these values are going to settle into something different here. So we're basically getting 65 frames per second for the animation. I saw render get something similar up in the mid-60s. And the actual frames per second for enter frame was 24, 26, 25, right around where it should be for the reported frame. Okay, so again, you'll see the render frames per second and the animation frames per second are just about the same, which makes sense because we get a timer event, we change displays, the display values, and then we send the render event, basically. We say update after event that sends the render event. So these are sort of one-to-one. And then the enter frame event is a little bit different. Now we can actually change the frame rate, which is an interesting thing to do. So we could pop this up and sort of see how that affects the system. So now we're getting a higher enter frame rate, although the animation and the render rates don't change. So we could pop this up even further. And again, we're not really getting a change here. What's happening is that the timer is being called at a steady rate internally in the Flash player. So no matter what our enter frame rate is, we're still getting timer callbacks at whatever the rate is that the Flash player has determined, probably the low resolution timer of the native system that I'm using here. So 64 frames a second, that's about 16 milliseconds, 15 milliseconds, which is about the rate of the Windows native timer. Or we could actually lower the current frame rate. So this is kind of interesting. If we lower the rate at which the Swift thinks it's going to play, you'll notice that actually affected the animation frame rate and the render frame rate. So I believe what's happening is we're basically throttling the amount of timer events. Somebody inside the Flash player must be saying, you know what, they don't actually want us to render very often, so we're not going to send out quite as many timer events. Maybe this application is actually trying to be nice to the system, or it's determined that it doesn't need to update that often, so it would be impolite for us to send out too many timer events. But we can see that although the values are not directly correlated, we definitely are impacted by a low frame rate in what we can do animations and render events at. So now quickly we'll look at the code to do this. For each one of these things, I track each of these events in exactly the same way, so I have the same set of variables for each one of them. I have the number of frame rates that's elapsed since the last time I measured this thing. I have the start time, which is the actual millisecond timer when I started calculating the current frame rate. I have the FPS that I calculate, and that's what's being posted onto the display. And I think that rate is probably not even being used. Oh, there it is. Oh, yeah, the rate is just a particular variable for the enter frame because I wanted to report, well, what does the Swift think that it's running at? So inside each of these calculations, we do basically the same thing. We say, well, increment the number of frames, and if we're just starting out, then go ahead and grab a time for the start time, and then grab a time for the current time, calculate the delta between them, and if it's greater than a second, then go ahead and calculate a new frames per second value and reset the values. Right? So this basically says every second that elapses, let's calculate a new frame value. The reason you want to do this is otherwise you're constantly updating the value on the screen. The numbers are flickering, and it's really hard to tell what's going on. You want to kind of amortize the frames per second over time so that you get more of a steady value that's a little bit more realistic. A, you can see it on the screen, and B, you don't have to wade through a lot of information. You can just see overall what is the general frame rate that I'm getting. And I basically do the same exact calculations for rendering and animation. And then the interesting part is how we actually hook into those to track them. So for the animation rate, I have this move animation declared here, and I say on effect update, which is an event that all Flex Effects send out, we're going to call that function anim update handler, and that's where we actually calculate the frames per second for the animation. We do some initialization for those values when the animation starts here. For render and the enter frame, those are hooks that I plug in up here. So we say for the overall application, whenever the enter frame event is sent, then we're going to call the enter frame handler. Whenever the render event is sent, then we're going to call the render handler. And then we go ahead and calculate those values there. And then in our GUI, we data bind to those values. So we report the rate there. We data bind to the FPS value, which is the rate of the enter frame events. We data bind to the FPS render, which we calculate based on the render events. And we data bind to the FPS anim, which is the rate that we calculate for the underlying animation. And if you want to see this application and other related stuff, go to my blog at graphics-geek.blogspot.com.